Okay, so as I mentioned to you guys yesterday, where we're heading is graphing polynomials. And they can look a lot of different ways. Don't do anything in your notes, but just look right here. Again, if you had a Cartesian plane, maybe that polynomial will look like that. And the key points of graphing this are the zeros, that point, and that point. Maybe the graph will look something like this. And again, the key points would be the zeros, that one, and that one, and that one, and that one. Occasionally it'll be a boring one, and maybe it'll only go kind of like that, and there'll only be one zero, and it'll be that point. But the zeros correspond to the factors of the polynomial. If you go all the way back to quadratics, if we were going to find the zeros of a quadratic, we would set it equal to 0, and we would factor it and set each factor equal to 0 and get the values of those zeros. That's what we have to do here. Even though it's not going to be quadratic, it's going to be a polynomial. So the key to everything is factoring. And to be able to factor, we've got to learn a couple things that will allow us to efficiently factor. Otherwise, these things get real big and real difficult. So the key are the zeros, and the zeros come from the factors of the polynomial. So all of what we're going to do today, and then again on Thursday, is to begin to teach us how to come up with the factors of the polynomial. And so there's some things we can learn that will allow us to limit where to look. We got to figure out how to look for the factors. And so that's what all of this is about, and it all leads towards that. So it's kind of a process. And so hang in there as we look at a couple different things in the situation. All right, first one. Given the function, and so we've got p of x, that could be anything. There could be a y there, right? Equals 2x cubed minus 4x squared plus 8x minus 10. And the first thing we want to do is we want to find p of 3. All right, we've done this before, right? You see p of 3, you say, oh, all I do is put 3 in for the variable, right? Everywhere where the variable is. So let's just go ahead and do that. So I'm going to, as always, when I substitute, I put a parentheses where that variable is. So I'm just looking at the blue polynomial, and everywhere where an x is, I'm putting a parentheses, right? And then I'll go back and put the 3's in red. So again, the blue polynomial, and everywhere where the variable is, I'm sticking in the 3. Okay, so this is going to end up being a 2 times a 27, right? 3 times 3 is 9, times 3 is 27. Order of operations, got to do the exponent first. Don't multiply first. Second part's going to be a negative 4 times a 9. The third part is a 24 and minus 10. So again, just for clarity's sake, what is this? 54 minus 36 plus 24 minus 10. And when all of that is done, p of 3 ends up equaling 32. So again, 54 minus 36, so what is that? 18. 18 minus 10, I'll do the back, is 8. 24 and 8 is 32, right? Everybody okay? We've done this before. We just simply put the value 3 in for the variable. Okay. Second scenario. We just learned long division. Let's do long division. All right, so front divided by front. And hopefully we all conclude, let's use a 2x squared. So this gives me a 2x cubed and a minus 6x squared. Remember, we're doing long division, so we've got to subtract this. minus a minus is a positive 6x squared, so that's a positive 2x squared at the bottom. You let your brain catch up. Okay, first step. Again, we just distributed the negative as well, added up the negative 4x squared and the positive 6x squared. Bring down my positive 8x. And again, we're going to divide the front by the front. So 2x squared divided by x is a positive 2x. And now I'll distribute, right? The x out in front times the 2x is a 2x squared. The negative 3 out front times the 2x is a negative 6x. And again, I'm subtracting. 8x plus 6x, right? Be careful, that's a positive 6x. So that gives me a positive 14x. Bring down my negative 10. All right, front divided by front. 14x divided by x is a positive 14. So x times that 14 is 14x. Negative 3 times 14, 28, 38, 42. Negative 42. And then remember, we are subtracting, right? And so we end up with a remainder of 32. Pull this down. All right? Remainder of 32. I'm not going to finish the final answer. If I needed the final answer, I would do that. I'm not concerned about the final answer. Why did I do these two examples? Just think for a second, don't say anything. Why did I just do these two examples? Do these two examples teach you anything? Do you see anything that correlates between the two examples? All right, anybody want to mention something? Josh?
Remainder and
Okay, hopefully you agree. These two values are the same. I could do 100 problems, and 100 times the remainder would come out the same. Now, before I go too far, don't put this in your notes. I just need you to think a little bit right here. So let's suppose instead of P of 3, again, don't put this in here. Let's suppose instead we wanted to do P of 4. What would I then divide into the polynomial to get the same remainder? Luke? It would be an x minus 4 would get me the same remainder. Let's suppose I wanted to do a P of negative 2. What would I then divide into the polynomial to get the same remainder? Abigail? It would be, and I'm going to write it this way for clarity's sake. She said x plus 2, which is correct, right? X minus a minus 2, which is an x plus 2. So that is correct. And that would give the exact same remainder. And we could do it 100 different times and it would turn out the same. The remainder from subbing in the value would be the same remainder by doing long division. Which one should be quicker, subbing in the value or long division? Subbing in the value. Which one should produce less error, subbing in the value or long division? Subbing in the value. So subbing in the value is way more efficient to get us to the remainder. Way more efficient to get us to the remainder. Now, can anybody see, if you start it this way, how to get back to those numbers to sub in? Like, what if you started with the x minus 3? How would we know to sub in a 3 if it were an x minus 3? How would you know to do that? You could just say, well, I just know. And you could, but there's a correlation. Does anybody see the connection? Okay, it's hard to ask the question, so you may not understand because it's hard to be clear in asking you the question. Abigail, you want to take a stab?
Whatever.
Pick the bottom one. X minus 3. How would we know to use 3? The 3 is there, and that's just by looking at it and understanding. By the way, you can make the correlation to, how about reading the h value of an x minus h quantity squared? Right? Isn't the same concept of reading the value of the h? So you could think of it that way. But think about this thing as what it really is, a polynomial. And think about it, if you had a quadratic, again, don't write this, I'm just trying to get you to think. If you had this as a quadratic and you were in the process of solving it, we're not done yet, right? And we would finish off by solving for the zeros, by the way. And how would you finish this? You know, you would do x minus 4 equals 0, so what does x equal? 4, and x minus 3 equals 0. Whoops. So what does x equal? 3. So again, we set this equal to 0. What is the value of 3? Set this equal to 0. What's the value of x of 4? X plus 2, set it equal to 0. What's the value of x? Negative 2. So it really comes from that. All right, students have a lot easier job just subbing in the number than keeping clear what to sub in. But that's the concept, and that's what we're talking about. All right, I got to get rid of all of this so when I review, it makes semi-sense. I should have just erased it. It would be easier, but that's okay. All right, so first off, concept. If we can sub in the value and figure out what it equals, and it would be the same thing with the corresponding divisor as the remainder. All right, that's the start of it. So that then brings us to this statement. Use my green here, the remainder theorem. The remainder theorem. And it just says if a polynomial p of x, and don't get caught up in the p of x, that's just simply a polynomial, is divided by a binomial of x minus, in red here I'm going to put an a, then the remainder will be p of a. You'd sub in that a into the function, right? So again, isn't that what we just did here? What's the a in this situation? The a is a 3, and didn't we sub 3 in and figured out the remainder? So this is the beginning. That's the first concept in the first shot here. All right, let's see if I can get rid of all this stuff. Okay, so let's do a couple situations. Find the remainder of 5x to the fourth minus 3x cubed minus 4x squared plus 3x plus 1 when it is divided by x minus 1. Go ahead and do that. I'm going to pause. All right, hopefully with those ones, you're there. So on 3, give me your solution. Here we go. 1, 2, 3. 2, right? You should have ended up with 2. And again, hopefully you didn't do long division. If you did long division, you're not following the concept. Right? Because the whole idea is to save us the hassle of doing long division. So sub in a 1 everywhere where you see the variable. Go ahead and multiply it all out. Be careful, follow the order of operations, and you should have gotten 2. So if we would have divided x minus 1 into that polynomial, we would have gotten a remainder of 2. All right, let's do another one. Go ahead and try number 2. Again, I'm going to pause. Remainder. All right, so on 3, give me your solution. Here we go. 1, 2, 3. 8, right? Should be the remainder if all's right with the world. Let me leave that up there and give you time to take a look at it and find your mistake if you've got a mistake there. Again, be careful with your positives and negatives, right? We're using negative 2. Negative 2 to the 4th power is a positive 16. Any negative to an even power will end up positive. Negative 2 cubed, though, be careful, that's a negative 8. And now you got a negative 3 times a negative 8 for a positive 24. Negative 2 squared is a positive 4. Now you got a negative 5 times a positive 4 for a negative 20. Minus 2, minus 10. Add it all up, you get to 8. All right. Do you guys have the word factor in B there? Okay. By the way, my numbers or my letters are all kind of crazy, but oh well. First edition notes, such is life. We went A, B, B, whatever, so it is life. All right, so first concept. The idea of figuring out the remainder. That's the first concept. All right. So the remainder theorem now leads us to the factor theorem. All right. So we're going to say this. A binomial, x minus a, is a factor. Not just getting a remainder, but is a factor. If and only if P of A equals... Does anybody know the answer? How do we know if it's a factor? Because look, here's the point. Believe it or not, technically, this x plus 2 is not a factor of this. It's not. You cannot factor this polynomial and get an x plus 2 as one of the factors. No more than you can take a 17 and get 2 as a factor. Is 2 a factor of 17? No. Can I divide 17 by 2? Well, I can divide it, but 2's not a factor of it. So yeah, I can divide this Come back. Where are you? I can divide this polynomial by the x plus 2, but it's not a factor of it. And up at number 1, we could divide that polynomial by x minus 1, but it's not a factor of it. And all the way at the top, in the first example, we could divide that polynomial by x minus 3, but x minus 3 is not a factor of it either. None of the beginning examples were factors. How do we know when it is a factor? Hunter? When P of A, were you going to say that? You can say it now. When P of A equals 0. That is the key. So we'll give you props for that, Joanna, because you had your hand up, unlike the rest of the chickens out there. No guts, no glory, right? Hey, the key is when the remainder is 0. Let me just go back to a quick analogy. You don't need to write this, but look, is 5 a factor of 20? What happens when I divide 5 into 20? Do I get a remainder? Nope. And any factor of something, when you divide it in, you'll get no remainder. Okay, so we're doing polynomials, and I know polynomials are, you got a bunch of variables and all that other stuff. But the reality is, if it divides in without a remainder, then it's a factor. So let's go back a couple days. Yesterday, actually. One day. So here I kept trying to make this analogy to you guys. Look at A here. I kept trying to tell you that this times this equaled that. And notice what the remainder was. 0. That's what we're talking about. So now, if we do the remainder theorem, and we happen to get a remainder of 0, we could say, hey, it's a factor. So we do just what we did a minute ago to figure out the remainder and see if we get 0. And if we get 0, we're happy. And if we don't get 0, we didn't find a factor. And you know what it's all about? Finding the factors. That's what this is all about. I need to find the factors so I can find the zeros so I can graph the polynomial. That's what it's all about. And I can't just start dividing anything I want into a polynomial. It'll take me forever. But I can start figuring some things out. So we got one more piece of the puzzle coming on Thursday. All right, well, what stuff do I start trying? There's like an infinite number of stuff. If I've got to figure out the factors of a polynomial, how do I know what even to try to see if I get a 0 remainder? Well, that's the last step, and something we'll learn, how to figure out what factors to even try to go for a 0 remainder. If we get that 0 remainder, we just found a factor. Hey, if we found the factor, how do we get the other factors? Long division. Now we'll get the other factors, and now we got all the zeros, and now we're ready to graph the polynomial. That's what it's all about. It's that progression. All right, that's enough for today. No homework today. Quiz tomorrow, though.